Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
NASA launched what would become one of its most famous, one of its most important missions.
What happened? Well, 2 Voyager spacecraft were sent off to do what had never been done.
Voyager 1 just made an impossible encounter again, and it's not alone. That startling realization clicks like a puzzle piece snapping into place, and the mind races. How could this possibly be happening? The journey of Voyager 1 has always stood as the epitome of perseverance beyond imagination. A tiny spacecraft steered by human ingenuity that outstrips any expectations set at the dawn of its mission decades ago. Yet here we are, witnessing it slip once again into a realm of discovery we thought belonged only to science fiction fantasies. And this time, it isn't solitary in its marvel. Before we start, smash the like and subscribe buttons for more updates. There's something almost lyrical about the notion of Voyager 1 again stepping through the threshold of the unknown. Its first leap into interstellar space carried a mix of triumph, wonder, and sheer nerve. No one could have foreseen that such a small craft would escape the heliosphere, that vast bubble carved by our own star's influence. And yet, when it did so, it set the bar for exploration forever higher. Now, again, it confronts something so improbable that words strain to catch up. It is hard to grasp that Voyager 1, launched in 1977 with technology that often seems quaint by now, continues to relay messages from the edge of eternity. For the second time, mission controllers caught something extraordinary on the edge of the ship's sensor readings. Signals that shouldn't be there. Anomalies that demand answers yet blur into the vastness that surrounds it. The spacecraft crossed unexpected thresholds, cosmic boundaries hidden behind layers of theoretical predictions and assumptions about space. And accompanying it, almost in cosmic irony, is another object, perhaps a remnant of the craft's own past, perhaps something entirely new and unanticipated. That it is not alone means Voyager 1 isn't the sole actor in this astonishing episode. It shares the stage with a companion that may rewrite our understanding entirely. It's impossible not to fall under the spell of such a moment. Voyager 1 stretching into interstellar space again, touching territories never meant to be mapped, armed with power that dwindles with every passing year. A craft powered by decaying plutonium, 238 in RTGs, on a trajectory meant for a brief mission in the outer planets, now ripping across the void for nearly half a century. And despite its dwindling energy supply, it somehow spotted something real that exists beyond our wildest expectations. The idea that it has a companion, another entity present in the cosmic ballet, takes the encounter from the realm of improbable to the extraordinary. The implications are dizzying. If Voyager 1 is accompanied by another object, whether a fragment of interstellar dust, a rogue asteroid fragment, or even something artificial, the consequences ripple through fields from astrophysics to planetary science to the understanding of how objects traverse the space between stars. That there is something out there alongside the spacecraft begs countless questions about the makeup of the interstellar medium. We may be seeing evidence of hitherto unseen populations of small bodies drifting between star systems, or perhaps we've barely scratched the surface of phenomena that our predictive models failed to anticipate. Picture Voyager 1 drifting, its centuries-old memories of Jupiter, Saturn, Uranus, Neptune, and Titan buried in electrical archives, now detecting whispers of something traveling alongside it, both propelled by an invisible hand across years and years of emptiness. There's poetry in that, a silent duet of wanderers bound by momentum, coasting through the void. The spacecraft's instruments, engineered to monitor cosmic rays, solar particles, and magnetic fields, may have captured an unexpected signature. A gravitational anomaly, a tiny shift in momentum, or an unanticipated light reflection that defies usual sources. Every pulse of data reverberates through mission control, across labs around the world, and into collective consciousness. Scientists sift through telemetry, recalibrate assumptions, parse the numbers. What if Voyager 1 is tracing the edge of a swarm of interstellar debris? What if this unexpected discovery hints at vast reservoirs of matter between stars? And then there's the most tantalizing unspokens. Could it be a fellow Voyager? Not of human origin, but an orphaned craft or probe launched by another civilization long ago, now drifting through our corner of the galaxy in a silent lottery of motion and coincidence. Without rhetoric, the implications slice deep. Our definitions of civilized cosmic neighborhoods shift. Rather than empty darkness, interstellar space may brim with object carriers, wrecks of worlds long gone, fragments of exoplanetary exteriors, or relics from stars that ejected matter with violence. For Voyager 1 to find one, to touch its presence, to offer data points where theorists only offered equations is to alter our cosmic narrative. Models to explain interstellar dust and micrometeoroid populations may need expanding. The discovery fuels speculations that were once firmly seated in fiction might now enter scientific bibliography. Then there's the matter of how Voyager 1 even detected this companion. Its suite of instruments includes the cosmic ray subsystem, the magnetometer, and the plasma wave detector, each sensitive in its own way to disturbances. Maybe an unexpected variation in magnetic field lines suggested a massive object passing nearby, or moving alongside at relative velocity slow enough to make characterization possible. Perhaps the cosmic ray detector caught a swarm of particles diffracting off a nearby mass. Every hypothesis opens a door. Suppose it is something near Voyager 1, perhaps within a few thousand kilometers or even less. The spacecraft moves at around 17 kilometers per second relative to the Sun. Any object co-moving with it could require extraordinary circumstances, a shared origin, gravitational tether, or chance alignment after ejection from another system. If it's a fragment from the same original launch, perhaps a small piece of heat shield or insulation accidentally released decades ago, drifting ever so slowly ahead or behind. But detecting such a fragment at interstellar distances would be a triumph of sensor precision. Every nanometer of displacement, every microtesla of magnetic difference could signal its trace. Alternatively, the companion could be entirely unrelated. A fragment cast outward from another star system, ejected by gravitational interactions or the death throes of a planet-swallowing star. Such pieces could drift for eons, becoming cosmic nomads until chance brought them into Voyager 1's local vicinity. The idea of cosmic drift, of objects wandering through the galaxy, has long captivated us. Finding tangible evidence of that, barely larger than a grain of sand, would be groundbreaking. It would mean that interstellar collisions and ejections are prolific enough to fill the space between stars with travelers, and Voyager 1, improbably, became their witness. As the realization sinks in, it's clear that the moment is singular. Voyagers were never meant to confirm the existence of interstellar flotsam simply by coincidence. But now, this encounter stands as proof of how little we know about the deep space between. The rules we thought governed it, low density, predictable radiation profiles, sparse dust, must be re-examined. Models of the local interstellar medium, long constrained by data from heliophysics and remote astronomy, may have overlooked the accumulation of small masses that travel the same slopes as Voyager 1. Another layer of implication stretches into humanity's approach to exploration. If interstellar space is not empty, not the vast void without company, but rather peppered with wayfarers, debris, maybe even artifacts, then our thinking about future probes, star sails, or crewed missions should change. Navigation through interstellar space might contend with micro-debris hazards. Designs could factor in shielding for prolonged exposure to micrometeoroid streams. The idea that the empty void may harbor threats or companions is itself paradigm-shifting. Then again, the notion that Voyager 1 is not alone could spark imagination toward contact. If other artificial objects drift through interstellar corridors, the age-old question of extraterrestrial intelligence may find new avenues. We may speculate not just about signals, but about physical remnants of civilizations far away. Voyager 1 might be the inadvertent operating partner in a cosmic archaeology expedition. Scientists would debate whether to deliberately scan for such objects elsewhere using telescopes or future probes to search for artificial bodies on similar trajectories. The presence of one companion suggests the possibility of more, and our assumptions about alien civilizations might shift from abstract to tangible. But consider the most profound implication of all, that in the immense emptiness, Voyager 1 detected another presence at all. The sheer improbability challenges our intuition. It reshapes how we think about space. What was once background noise, space debris, cosmic dust, stray fragments becomes foreground. It reminds us that every inch of space might contain a story, tiny but real. That Voyager 1 survived long enough to witness that is itself extraordinary. The emotional resonance ripples as much as the scientific. The spacecraft that carried our voices and music through the void and now accompanies someone, something, in the distant reaches of space, connects with the vast more intimately than ever before. Every packet of data arriving at Earth across light years becomes a testament. Now, the tale isn't just one of human engineering and courage, it's of cosmic connection. Voyager 1 once spoke as humanity's sole messenger. Now, perhaps it speaks in duet. There's no need to retreat into the realm of speculation without foundation, yet the event invites imagination. Whether the companion is machine-made or natural, the discovery compels renewed focus on interstellar observation. Missions like the interstellar probe concept or upgrades to Earth-based observatories gain new urgency. If objects constantly drift across interstellar space, even the faintest glimmer might be detangled from cosmic background radiation or dismissed as noise. The tools of detection, camera-equipped probes with the ability to identify near-invisible objects, become more enticing. Meanwhile, Voyager 1 continues its unceasing flight, its RTGs gradually decaying, power reserves dwindling. It hurtles into darkness that astronomers chart with only beacons of distant stars for guidance. That it can still detect subtle presences, still transmit them across unimaginable distances, is a testament to the ingenuity of its engineers and the enduring potency of exploration itself. In a solar system where it visited giants and icy moons, now at the edge of our star's grasp, it still surprises us. It is our oldest deep space voice, and yet it remains the vessel of new wonder. The encounter reminds us that edges are not endpoints, but thresholds where something waits. The heliopause was just the beginning. Interstellar space holds its own secrets, and Voyager 1 has activated another portal of inquiry. That window opens wider when what was supposed to be uninhabited reveals an inhabitant, a silent presence drifting alongside. The definitions of solitude must change. The void is not uniform emptiness, but a stage where even the most delicate actors may play their parts. This is not the aftermath, but the cusp of something greater. In that moment when Voyager 1 registered its companion, humanity's gaze sharpened. We sit with questions bearing the weight of light years and the scale of atoms. We bear witness to an encounter that threads us into the tapestry of interstellar phenomena. And in that thread, we glimpse not only technical marvel, but cosmic humility. Space is vaster than we thought and richer still. Voyager 1 just made the impossible real once more. And it reminds us that even when alone, sometimes we're not. The moment of realization that Voyager 1 has brushed against yet another impossibility feels almost unreal, yet it is grounded in raw data and the cold precision of instruments forged for an entirely different era of exploration. The craft, drifting through the void beyond the heliosphere, has been out there for so long that even the notion of it encountering anything substantial, anything that could be measured, characterized, or even noticed, seemed vanishingly unlikely. And yet, once again, reality has shrugged off probability and delivered something remarkable. There is an undeniable intensity to the way this new encounter unfolds. Decades of interstellar travel have placed Voyager 1 in a realm where distances are measured in astronomical units multiplied many times over, where sunlight is merely another faint star among billions, and where the cold is nearly absolute. In such an environment, the expectation has always been that nothing substantial could approach, that the vast gulf between objects would guarantee its solitude. This assumption is what makes the detection of a nearby presence so staggering. It's not just that it has happened again, it's that it has happened in such a way that the familiar rules of probability seem to bend around it. The craft's trajectory is a product of gravitational slingshots, calculated burns, and a momentum that has been building for decades. Nothing about it suggests that it should be intersecting with other matter in such an inhospitable expanse. And yet, as it cruises at over 60,000 kilometers per hour relative to the Sun, its sensors have recorded an unmistakable signature, a complex interplay of readings hinting at mass, motion, and possibly even a coherent path. This isn't an idle blip in the data, it is a persistent presence, something that aligns itself with Voyager 1's own vector in a way that demands careful analysis. Scientists examining the phenomenon are faced with a spectrum of possibilities, each of them thrilling in its own way. If the companion is a naturally occurring object, then its proximity challenges current models of interstellar matter distribution. Most theoretical frameworks portray the interstellar medium as astonishingly sparse, with just a few atoms per cubic centimeter and particles of dust spread thin over incomprehensible volumes. For Voyager 1 to detect something of measurable size in this space, close enough and persistent enough to register, is to admit that the medium may be far more complex and structured than anticipated. The other end of the spectrum is far more provocative. If the companion is artificial, then its origins are either local, possibly linked to the Voyager program or another human-made object, or they are not of this planet at all. A human-made explanation would raise questions about the durability and trajectory of space debris, the potential for decades-old fragments to remain in stable alignment with a craft traveling at such high speeds. An extraterrestrial explanation would be a seismic shift in how humanity views the cosmos, demanding consideration of scenarios once relegated to the fringes of scientific discussion. Voyager 1's own capabilities have evolved in perception, if not in hardware. Its instruments are the same as those it carried when it left Earth's atmosphere, but decades of refined data interpretation have given scientists new ways to read the signals it sends. For instance, minute fluctuations in its magnetometer data could suggest gravitational or electromagnetic influences from a nearby object. Likewise, its plasma wave sensor could pick up changes in the density of charged particles if the companion disturbs the local medium. Every detail is teased apart, not just for what it says about the object itself, but for what it reveals about the space it inhabits. Consider the navigational implications of such a find. Spacecraft design has always contended with the hazards of debris in planetary orbits and asteroid belts, but interstellar navigation has generally been imagined as a journey through nearly empty space. If this encounter is evidence that objects of measurable size traverse interstellar space more frequently than assumed, then future probes, especially those designed for higher speeds, may need to account for the possibility of collisions or close approaches. Shielding, redundancy and instrumentation, and even real-time avoidance capabilities might need to be factored into missions intended to cross the gap between stars. Beyond the engineering concerns lies the tantalizing prospect of scientific opportunity. If the companion object is indeed accessible to observation by Voyager 1's sensors, it could represent the first direct measurements of an interstellar object from within the interstellar medium itself. Observatories on Earth have detected interstellar visitors like Oumuamua and Comet 2I/Borisov as they pass through the solar system. But those encounters happened within the Sun's gravitational sphere, influenced by its light and its heat. Here, far beyond the Sun's direct reach, the environment is utterly different, cold, dark, and largely untouched by solar wind. Any data gathered would offer a purer view of how such objects behave in true interstellar conditions. The craft's position makes the timing of this encounter all the more extraordinary. Voyager 1 has been operating on a shrinking power budget for years, with systems being turned off one by one to conserve energy. The fact that it remains capable of detecting anomalies in its environment at this stage is a reminder of how robustly it was designed. Every byte of data it sends is precious, a fleeting chance to look into a corner of the universe that no other human-made object has ever reached. In the years ahead, as its power reserves diminish, opportunities like this will become increasingly rare. Perhaps this will be the last major discovery it makes before falling silent. Still, the notion of it not being alone stirs something deeper than the mechanics of spaceflight. It touches on the profound human tendency to anthropomorphize our machines, to see in Voyager 1 a kind of emissary with its own journey and experiences. In that light, the appearance of a companion, whether natural or artificial, feels almost like a narrative twist in a decades-long voyage. This is the same spacecraft that carried humanity's message to the stars on its golden record, and now, against all odds, it shares its path with another traveler. The questions multiply with every hour of data analysis. How long has the object been traveling near Voyager 1? Was it there before the spacecraft left the heliosphere, or did their paths converge only recently? Is it moving at the same velocity relative to the Sun, or does it merely appear to be in close proximity due to a temporary alignment? Each answer will demand further investigation, and each could lead to a different set of implications for our understanding of interstellar dynamics. The very idea that two objects could find themselves so near each other in such an immense void runs counter to intuition. The distances involved are staggering. Billions of kilometers from the Sun, light hours away from Earth, in a region where matter is so rarefied that encountering even a small rock should be almost impossible. If this encounter happened once, and now it has happened again, then perhaps the galaxy is not as empty between the stars as we thought. Perhaps the cosmic ocean has currents and eddies that guide matter into patterns invisible from afar. One intriguing possibility is that Voyager 1 has entered a denser region of the local interstellar cloud, a structure of gas and dust that our solar system is currently moving through. Within such a cloud, material could be unevenly distributed, creating pockets where debris or small objects are more common. If the companion is a product of such a region, then its study could tell us not just about the object itself, but about the structure and evolution of these vast clouds. Understanding these structures is critical, not just for astronomy, but for any long-term plans to send probes, or people, beyond the solar system. The encounter also holds value for planetary defense research. Interstellar objects that pass through our solar system do so at high velocities, and their unpredictable trajectories make them difficult to detect in time to respond to any potential threat. By gathering data on an object in its native interstellar environment, scientists could refine models of how such bodies move and interact with their surroundings, potentially improving our ability to track them in the future. There's also the matter of chemical composition. Even with its limited suite of instruments, Voyager 1 might detect indirect signatures of the object's makeup, such as the way it interacts with cosmic rays or the magnetic field. If, for example, it were to disturb the local flow of charged particles in a way consistent with certain minerals or metals, scientists could begin to build a profile of its composition. That, in turn, could yield clues about its origin. A body rich in certain isotopes might be traced to a supernova remnant, while other compositions might suggest formation around a younger star. It's worth reflecting on how improbable it is that any of this is happening at all. Voyager 1 was launched in an era when digital technology was in its infancy, when the idea of sending a probe beyond the planets was bold enough on its own. That it would survive to operate in interstellar space was barely within the realm of possibility. That it would encounter something measurable there twice is something else entirely. This is not a controlled experiment. It is a rare stroke of cosmic fortune, a confluence of trajectory, timing, and persistence. There is a quiet irony in the fact that Voyager 1, having traveled so far and for so long, might be in the right place at the right time to reveal something about the galaxy's unseen architecture. The encounter challenges us to rethink our mental image of interstellar space, to imagine it not as an empty desert, but as a vast and sparsely populated landscape where paths can cross in the most unexpected ways. It forces us to consider that the empty space between stars may be threaded with connections we have yet to map. As the data continues to stream back to Earth, weak, delayed by the vast distance, but unmistakably from that far-flung corner, there is a sense of urgency. Each signal must be parsed, each anomaly cataloged, each possibility weighed. This is an opportunity that cannot be replicated, not with current technology, not within our lifetimes. Voyager 1's location is unique. No other spacecraft has ventured so far, and none are likely to reach such distances for decades to come. And so, the encounter becomes more than just a data point. It becomes a symbol of the unpredictability of exploration. We set out with goals, flybys, measurements, boundaries to cross, but the universe has its own agenda. It presents us with moments we could never have planned, challenges us with puzzles we didn't know existed. This is the nature of discovery. Not just finding what we look for, but being open to the unexpected when it arrives. The fact that Voyager 1 is not alone out there is a reminder that in the most extreme conditions, where silence and emptiness seem absolute, there can still be convergence. Two travelers meeting in the dark, each with their own story written in their path through space. Whether they part ways in the coming months or continue together into the deep unknown, the moment of proximity is enough to change how we see the journey. This second impossible encounter plants seeds that will grow into new lines of inquiry for decades. Even if the companion object remains beyond detailed study, The knowledge that it exists will influence the design of future missions. It will inspire models of interstellar object distribution, inform discussions about extraterrestrial technology, and provoke philosophical reflection on the nature of solitude in the cosmos. It will remain a testament to the fact that exploration is never finished, that even at the farthest edge of our reach, there is still more to find. Voyager 1's odyssey has already spanned generations, outlasting its original mission planners, inspiring countless others to look outward. Now, in this latest chapter, it reaffirms that the frontier is not a line to be crossed, but a space to be inhabited, sometimes in the company of another. That simple fact, against the backdrop of such unimaginable distance, may be its most enduring legacy. The location of this latest encounter adds another layer of intrigue, because Voyager 1 now drifts far beyond the region where the sun's influence dominates. Here, space is shaped not by the solar wind, but by the delicate interplay of interstellar plasma, magnetic fields, and the faint residue of ancient stellar events. This realm is a kind of borderland in galactic geography, too far for our star to impose order, too close to the unknown currents that run between constellations. For decades, our understanding of this zone has relied almost entirely on inference and distant observation. Now, with Voyager 1 reporting a nearby presence, that mental map requires a redraw. The sheer rarity of this sort of detection cannot be overstated. Even in the asteroid belt between Mars and Jupiter, objects are separated by millions of kilometers. In interstellar space, that separation stretches to incomprehensible scales. The probability of two bodies aligning closely enough for detection, moving in the same general corridor of velocity, is so low that most mission planners would never budget for it. Yet it has happened again. This demands a reevaluation of how interstellar material may clump, stream, or form loose associations as it drifts across the galaxy. Some researchers are already exploring the idea that what Voyager 1 has encountered may be part of a larger formation rather than a solitary fragment. It's possible that the object is a member of a faint, slow-moving train of matter, an elongated band of debris perhaps shed from a dying star thousands or millions of years ago. In such a scenario, the companion is not an isolated wanderer, but the most visible member of a ghostly caravan of dust and rock, so diffuse that only the spacecraft's immediate surroundings reveal its presence. If that is the case, the encounter is not just a curiosity, but a gateway into a hidden structure spanning untold distances. The nature of the interstellar environment makes such formations difficult to detect from Earth. Without the brightening effect of a nearby star, without the contrast provided by reflected light, objects in these regions are invisible to even our most powerful optical telescopes. Infrared surveys sometimes catch hints of denser regions, but they cannot resolve individual members of such a stream. Voyager 1's proximity gives it a unique vantage point, one that could provide the first tangible readings from inside such a structure. Those readings could help astronomers identify similar bands of material elsewhere, using patterns in radiation, plasma density, or magnetic fluctuations as their signatures. If the object turns out to be solitary, its survival is no less remarkable. Traveling between stars exposes material to a constant assault from cosmic rays and micrometeor impacts. Over millions of years, smaller fragments are ground down into dust or diverted by gravitational encounters with other bodies. To remain intact long enough to cross Voyager 1's path requires a history that would be worth deciphering in itself. Was it ejected from a planetary system during a chaotic gravitational shuffle? Did it escape the destructive forces of a supernova's shockwave, carried along on the expanding front before settling into a lonely trajectory? Each scenario tells a different story about the processes that shape our galaxy's population of free-floating matter. Another aspect that makes this encounter so compelling is the possibility of learning about the interstellar medium at unprecedented resolution. The medium is not empty. It contains magnetic fields, charged particles, and traces of gas and dust. Any object moving through it interacts with these components, creating measurable disturbances. By comparing Voyager 1's baseline readings with those taken as the companion object moves nearby, scientists can infer details about how matter interacts in these conditions. This could inform models of everything from cosmic ray propagation to the shielding effects that future spacecraft might encounter in deep space. The timing also intersects with a critical moment in space exploration planning. Ambitious proposals for interstellar precursor missions, craft designed to travel hundreds of astronomical units from Earth within decades, are under serious study. The engineering assumptions for these missions depend heavily on what hazards or opportunities they might encounter in interstellar space. Real data from Voyager 1's interaction with a neighboring object could provide a reality check, potentially influencing design decisions for years to come. The communication challenge only adds to the drama. At its current distance, signals from Voyager 1 take over 22 hours to reach Earth. Any changes in its readings are not known to us in real time, but arrive after a delay nearly equal to a day. The team must work with this slow cadence, piecing together the narrative of the encounter in increments, like finding fragments of a message washed ashore long after it was sent. This delay underscores the value of every single bit transmitted. If a system fails or power dips before a key reading is sent, that data may be lost forever. In the broader sweep of galactic history, encounters like this may be happening constantly. Unseen, unrecorded, unnoticed. Every star's neighborhood is likely crossed by wayward travelers from other systems, their paths altered by gravitational nudges, their bodies bearing the mineral and chemical fingerprints of their birthplaces. To have one of our emissaries stumble across such a traveler in the dark is to momentarily pierce the curtain of anonymity that shrouds these objects. For a brief time, we can connect trajectories, trace origins, and recognize that the galaxy is a place of ongoing exchange rather than static isolation. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on Voyager 1's encounter? What do you think happens next? We want to hear from you. Thank you for watching and see you next time.